So our first section is 1.1, evaluate expressions. So just like a few little definition things here. A variable is a letter used to represent one or more numbers. And variables have number values assigned to them. Sometimes they're told to you, sometimes you have to solve for them. But yeah, anyways. An algebraic expression is an expression that includes at least one variable. So just as like a couple of like little examples here. So for like multiplication, just a couple different ways to like notate it. You could see something like 3 times m, where it's written in parentheses. You could just see it as 3 with an m beside it, like that. Or you could possibly see it as 3 with the little dot for multiplication and then m. If you're used to using like an X for writing multiplication, you're going to not want to do that anymore. You're going to want to switch to the dot or to like parentheses or something, because our textbook doesn't do it quite as much, but in most textbooks, X is the primary variable that gets used. So if you're using the multiplication symbol of like an X, it's going to get really confusing. So this is just 3 different ways to write the exact same thing. For division, we can either write it as like 5 over y, where it's like written as a fraction, which would be 5 divided by y, or we could write it as 5 with the normal little division symbol, the line and the dots, divided by y, like that. There's no really fancy way to write addition and subtraction. Addition is obviously just like, 3 plus x, and subtraction 4 minus n, or something like that. So really just multiplication and division. There's multiple ways that we can write them, but all of these would be algebraic expressions. And sometimes they'll tell you like m is equal to 7 or something like that, and you'll plug it in, and then sometimes you'll be like, eventually we'll get to where we're solving for the variable to see what the variable is equal to, which I assume y'all have done a little bit of that with pre-algebra last year. Let's see, expressions using exponents. So essentially I'm just going to do this by showing you an example. So if I had like 4 to the 3rd power, like that, this whole piece here is called a power. the number 4 is the base, and then the little 3 up here is the exponent. And so what this means is essentially that this is 4 times 4 times 4. And you don't have to necessarily, I think there's a couple in our book that want you to like write them out, but you don't necessarily have to write them out like this. You can just kind of like do it. But 4 to the 3rd power is 4 times 4 times 4. So 4 times 4 would be 16 times another 4 would be, well, actually, we don't need to do that with this, but it would be 64. So essentially your exponent is whatever you're raising the base to. But those are just kind of like the names for the stuff. Yeah, that's all the like notes, definition stuff that you really need. So we'll jump into some examples. So I usually do a pretty decent amount of even problems for you, and then I'll assign you some odd problems to do for your homework. I would say that most days you'll probably have at least 15 minutes to work on problems, so you may not really have that much homework. Last year I had some parents being like, do you not ever give homework? I was like, no, I do. They just finish it in class. So if you finish it in class, that's great. If you finish it at home, also totally fine. Doesn't matter. Some days you'll have time, some days you won't. All right, so these first ones, we are going to be evaluating the expression. So number 4, so anytime you're doing your homework problems, you should be writing out what the problem is. You don't need to like write the instructions, but write out what the problem is. So this one is 0.4 times r when r is equal to 6. So what they want us to do with this one is they want us to basically replace the variable with whatever they tell us it's equal to, and then just to solve it out. So this would be 0.4 times 6. I usually use parentheses because that way if I have a negative number that's getting plugged in, it doesn't get confusing. You don't think, oh, I'm subtracting when you're really multiplying. It's up to you, but that's what I think works the best and causes the least amount of error. So does anybody know what 0.4 times 6 is? You can just say it.
2.4.
Yep, 2.4. Because 4 times 6 is 24. We move the decimal place one time, and so it would be 2.4. Let's see. 6. 1.6 minus g when g is equal to 1.2. So I'm going to plug in 1.2 for g. So I'll have 1.6 minus 1.2. And what would that be equal to?
0.4.
Yep,
Yeah, 0.4.
Yep, 0.4. Let's see, 10. I've got t over 5, so it's division, but it's written in fraction form, when t is equal to 4.5. So I'm going to plug in 4.5 for t. So 4.5 divided by 5. Does anybody know that off the top of your head?
0.9.
Yep, 0.9. If you don't know that off the top of your head, or if you just want to see a refresher on some division, we do 5 into 4.5. Then we put the decimal place where it goes, and then we would do 9 there. 9 times 5 is 45. And subtract, that would be 0. So 0.9 would be what you get if you did your long division that way. I don't do long division very often, so I have to always like refresh on like how I'm doing it. Let's see. How about 12? 1/2 times k when k is equal to 2/3. So again, when I'm multiplying, I like to use the parentheses just to help with confusion. So what happens when I multiply 1/2 by 2/3?
3/6, which equals 1/2.
1/3. So remember, you're multiplying. You added. But you technically can't add that way either. So, well, I guess you added the top, but you multiplied the bottom, I think is what you said. But yeah, so remember, if you have fractions that are being multiplied, we can reduce stuff top and bottom, so the 2's would cancel, and then that leaves us with 1/3. The next problem, say to write the power in words and as a product. I'm not really that worried about you writing out in words what's happening, but you do need to write it out in like as far as like the product of whatever. So for 16, we have 12 raised to the 5th power. So you don't, basically what I just said, you don't need to write it out. So like you don't need to write this is 12 to the 5th power. Just show me that you know that this is 12 times 12 times 12 times 12 times 12. 1 second.
Hello.
What's up? Okay. Beautiful. Yeah, I'm not sure. So Emma O's has come in now. Okay, perfect. Yep, nope, she had the appointment this morning. That's why I wanted to check, so. Perfect. Perfect. Awesome. Thank you. Appreciate it. Oh, thanks. Okay, bye. Okay, back to our regular scheduled programming. How about if I have this one? 1/2 raised to the 8th. What do I need to do with this one?
1/2 times 1/2 times 1/2 times 1/2.
And so on and so forth. So you're basically just writing 1/2 8 times. I'm already losing count. What is that, 6? So basically that's all you need to do on those ones. You don't need to write it out in words. If you want to, that's fine, but you don't have to. Last year, because I know y'all weren't using like the actual textbook or whatever, did y'all have any problems that said to like describe and correct the error? Or have you ever done those before? Okay, I'm gonna go over one with you from this section because sometimes in like other sections we'll have them. So these ones say describe and correct the error in evaluating the power. So they have a problem that is 0.4 squared is equal to 2 times 0.4 is equal to 0.8. So what they want you to do is, this is what they have told you, but they're telling you that it's wrong. Okay, so you need to find the error and fix it. So what I usually tell people to do is to write the problem statement down, to write like 0.4 squared, and then solve it the way it should be, and then figure out what the student that did this did wrong. So how would I write this correctly? Yep, 0.4 times 0.4. And so then what would that be equal to?
1.6.
Point what?
0.6
1/6. 4 times 4 is 16. Move the decimal place twice. So essentially, they multiplied instead of raising it to a power. So I would just say something like that. So they multiplied by the exponent instead of multiplying it by itself. And there's different ways you can word it. Obviously, it doesn't have to be worded exactly that way, but that's just how I did it. Like the way the book writes it is 0.4 was multiplied by 2 instead of squared. So however you want to write it is fine as long as you explain what they did wrong.
Wouldn't the 0.4 times 0.4 be 1.6?
No, because you move it 2 decimal places. So every decimal place you have, it has to get moved over 2 times. So if it was like 4 times 0.4, then it would be 1.6 because both of them are 0.4. We have to move it twice. Gosh, the thing keeps going off. All right, evaluating the power. So this time up here, they just wanted us to write them out. Now they want us to actually say what it's equal to. So if you need to write them out, you're welcome to, but if you can just go to an answer for these ones, that's okay as well. So like if you had 26, 3 raised to the second power, or 3 squared, that would be the same as 3 times 3, which is what? 9. So like I said, if you want to write it out, you can. If you can just say 3 squared is 9 and you know that, that's also okay. What is 1 raised to the 5th power?
1.
Yep, just 1. Let's see, 32. 2 raised to the 6th power. Does anybody know that off the top of their head?
32.
One more. Yeah, 64. So another way that you can, if you want to think about this a slightly different way, you could do 2 times 2 times 2, which is 8, and then there's another set of 2 times 2 times 2, which is 8, and 8 times 8 is 64. If you want to do it that way, you can just keep multiplying. I usually just keep doing 2 times 2 until I get to the amount that I need, if it's not one that I know off the top of my head. But there's all different ways, obviously, that you can do it to get there. But let's do one that's a fraction. 36. 2/3 raised to the 4th. So this one would be, well, I'm going to give you a little, I'm going to say like cheat code that you haven't learned yet, probably. Well, you may have talked about it in pre-algebra, but
81.
you already know it. Good. Yes, that is right. So the other way you can think about this is individually, that this is 2 to the 4th over 3 to the 4th, and then you can just think of each thing individually. Is that how you did it? Or did you just, okay, yeah. Because rules of exponent say that whatever exponent is here, it goes on to both pieces like that, and so you can do it that way also. Or you can just write out 2/3 4 times and then just multiply across the top, multiply across the bottom. That's also totally fine. And anytime you can reduce, I can't with this one, but if I could reduce the fraction, obviously you need to make sure that you are reducing. All right, evaluate the expression. And you're going to notice some of these things have more or less the same instructions. They're just the actual problems are just a little bit different. So 38, we've got x squared when x is equal to 3/4. So these ones are just using powers now to do the same thing we were doing earlier in the section. So if I take 3/4 and plug it in, Again, this is important that you're using those parentheses so that you make sure you're getting both the 3 and the 4 raised to the second power. So this would be the same thing if I wrote it like I did this one up here as 3 squared over 4 squared. And what would that be equal to? 9 over 16. Yep. And 42, W minus Z when W equals 9.5 and Z equals 2.8. So we're going to plug these two in. So we've got 9.5 minus 2.8. Now, if you think it's easier and you want to stack the numbers so that it's written like 9.5 minus 2.8 this way, because I think this is easier, you can also do it that way and then just do your normal subtraction. So then we can make this an 8, make that 15. 15 minus 8 is 7. Bring down my decimal. 8 minus 2 is 6, and so I would get 6.7 is my answer to this one. All right, this last problem, I want you to try this on your paper and see. This is a multiple choice question, so it says, which expression has the greatest value when x equals 10 and y equals 0.5, and they want to know, if it's A, which is x times y, if it's B, which is x minus y, C, which is x divided by y, or D, y divided by x. So take a minute and see if you can figure out which one it would be. And if it helps you to think about the decimal as a fraction instead, you can obviously convert it to a fraction as well. Do we have a guess yet? Taylor says A. Drew, what do you think?
C.
C. B. Nobody thinks D, though. That's good, because D is the smallest one. The answer is C. So 10 divided by 1/2 would be the same thing as 10 times 2, and that would be 20. So that would be why it's C. The other one, B, is 9.5, and then X times Y would have been 5. So, any questions on that one? All right, your problems are 3 through 41 every other odd. So I'm going to write out, normally I will not write out for you exactly what that means. I'm just going to tell you it's every other odd, or we might do every odd sometimes, but this would mean you do 3, you skip the number 5, you do 7, you skip 9, you do 11, skip 13, do 15, skip 17, do 19, skip 21, do 23, skip 25, do 27, skip 29, do 31, skip, I may have miscounted, skip 30, hold on, I'm saying this and I'm getting confused. 23, 27, yeah, okay. 35, and then skip 37, 39, so this actually should be 43, not 41. There we go. Page 5. So this would be the list of problems. So I know that in the middle school classes, y'all have like a heading that you're supposed to put at the top of every paper. That's like your name and date and all that. I don't really care about the date. The only thing I really care about is name and the section number. So like this is 1.1, and then that you write out the problems. So at the top of your paper, put like name and then section number, so like 1.1, and then list out the homework problems after that. If you want to put your date, the class period, and all of those things on there that you're doing for other classes, that's fine, but I need these 2 things on there so that I can make sure you get credit for them. Any questions about that? You can put that in the bottom box over there. If you have your syllabus signed and you haven't turned it in yet, you can put it over there.